The story so far. Inertia means laziness, the tendency things have to keep on doing what they're already doing. Big things aren't always lazier than small things. It all depends on how much mass they have. The more the mass, the more the inertia. And now, speed. Here is a red ball, and here is a blue ball. Although they're both the same size, the red ball has exactly twice the mass of the blue ball, which will take more effort or force to throw. The red ball or the blue ball? Of course, because it has more mass and therefore more inertia. And the only way to overcome inertia is to use force. But how much more force will it take to throw the red ball? Try it and see. First, the blue ball with 1 kilogram of mass. Then the red ball with 2 kilograms of mass. Exactly twice as much force, as a matter of fact. If you double the mass, you double the force needed to make it move, or to make it stop moving. In other words, if the inertia is doubled, the force needed to overcome it must also be doubled. But what if you pitch the red ball, say at a speed of 20 kilometers an hour, and then pitch the blue ball at twice that speed, at 40 kilometers an hour? Are you still putting twice as much force into pitching the red ball as into pitching the blue ball? Of course not. You'll be putting exactly the same amount of force into pitching both. Why? Because the difficulty of making a thing move not only depends on how much mass it has, but also on the speed at which you want to make it move. Or rather, on how much you want to change its speed. Doubling the mass doubles the force, and doubling the change of speed also doubles the force. Suppose that changing the speed of the blue ball from 0 kilometers an hour to 20 kilometers an hour requires 1 unit of force. Then getting the same ball to go from 0 to 40 kilometers an hour will require 2 units of force. But we also know that it requires twice the force to get the heavier red ball up to the same speed as the lighter blue ball. Therefore, getting the blue ball up to 40 kilometers an hour requires precisely the same amount of force as getting the red ball up to 20 kilometers an hour. Naturally, all this also applies to catching a ball, to stopping it moving. It will take as much force to stop the lighter blue ball going at 40 kilometers an hour as to stop the heavier red ball going at half that speed. Force varies with mass and change of speed. This tennis ball has a mass of about 50 grams. This cannonball has a mass of about 20 kilograms, or 20,000 grams. Obviously, the cannonball has more inertia than the tennis ball. It will take much more force to make it move or to make it stop moving because of its enormous mass. But now look at what effect speed can have. If someone serves the tennis ball at you fast enough, it can knock the racket clean out of your hand. Whereas if the cannonball dribbled out of the cannon slowly enough, you would be able to catch it quite easily. Stopping something means changing its speed. It can take more force to change the speed of a fast tennis ball than to change the speed of a slow cannonball. Change of speed makes a big difference.